Okay, the calendar says we're doing the ideal gas law and the combined gas law. We're just going to do the combined gas law today. We'll do the ideal gas law tomorrow. So today is the combined gas law. Well, I'm working on it. You will have another worksheet today / tonight. This law is Boyle's law. Jade, what two factors of a gas are focused on in Boyle's law? Charles' law. Max, what two factors of a gas are discussed in Charles' law?
Temperature.
And Gay-Lussac's law. Derek, what two factors are discussed in Gay-Lussac's law? So this isn't named after somebody. This is just the combination of those three laws into one formula, one equation. Now, keep in mind that pressure and volume are inversely proportional. This means if you were to double one, you multiply it by 2, which means you would divide it by the other. You would divide it by 2 on the other. Pressure and temp are directly proportional. If you multiplied one by 2, you multiply the other by 2. And volume and temp are directly proportional. The equation for these two is as follows. P1 times V1 over T1 equals P2 times V2 over T2. If you notice, P1 and V1 are still multiplied. That's indicative of Boyle's law. They are inversely proportional. But when you divide them by temperature, that number is going to be directly proportional. There are 6 total variables here. How many of you think that you will be provided on any given problem? You will be given 5. It's your job simply to identify those 5 and to put them in the proper place. That's it. You have to be able to isolate various variables. So I think you guys could stand for some practice with that before I get to an example problem. So let's do a few practice problems just by isolating a variable. That's it. Just isolate a variable. So let's do a test run. Let's say that you're given P1, V1, T1, P2, V2. You are not given T2. How would you go about isolating T2 so that you could solve for it? Any ideas? Arshan. So you want to cross multiply. So you would have P1 times V1 times T2 equals T1 times P2 times V2. So this is not chemistry right now. This is math. This is algebra. You want to cross multiply whenever you're trying to find the denominator. And now, Arshan, you're right, but we still have T2. How do we get T2 by itself now? You divide P1 and V1 on both sides. That's right. And so now you'll be having T2 on one side, T1, P2, V2, P1, V1 on the other side. So that's how you would solve for T2 or T1 if necessary. Okay, let's try another one. P1 times V1 over T1 equals P2 times V2 over T2. Jade, what if we were given P1, V1, T1, P2, T2, but we do not have V2? How do we get V2 all by itself? What do you think? Okay, so she says multiply both sides by T2. So T2 cancels out. So let's see what she has so far. Here's what we have. T2 times P1 times V1 over T1 equals P2 times V2. Okay, Jade, we still need to get P2 by itself. So what do you do? Okay. So you're right. Your new equation will be T2 times P1 times V1 over V2 times T1. And you just plug in your numbers. Yes, Kevin? We were solving for P2, right? Right? Oh, V2. You're right. My mistake. Better? All right. Max, last one. P1 times V1 over T1 equals P2 times V2 over T2. Max, what if on a problem like this, you're given P1, V1, T1, T2, V2, you're not given P2. How are you going to get P2 all by itself so that you may solve for it?
I'm not really sure.
Look at what Jade did. What's the first thing that she did when she tried to find V2?
Cross out.
What math did she do? You can't just say cross out the T's. What did she multiply?
T2
Where?
in the equation.
On both sides, Max.
Yeah.
In algebra, you cancel out. Here's the most basic algebra problem I could ever give you. If I said x plus 3 equals 4, how would you find x?
Subtract
You do it to what?
both sides.
Both sides. That's what I'm trying to get you to say. So x equals 1. So she did the same thing here. She multiplied T2 by both sides. So start off here. What would you do first?
Multiply, T2 by both sides.
That's right. Okay, good. So T2 cancels out here. You see why we did that? You're canceling out and you're going to move it over here. And so now, if I were just to clean this up, here's how it looks right now. T2 times P1 times V1. And what's on the bottom, Max?
Nothing.
Max, T1 is still there.
Oh, T1. Oh, no.
Yes, T1 is equal to what? What has not been canceled out so far on the right side?
T2 and
That's right, P2 and V2, okay? Well, remember that we are given V2, we're not given P2, so I'm still trying to isolate P2. What can we do next to get P2 by itself?
multiply T2 by both sides.
No, you don't multiply. You want to cancel out V2. Multiplying isn't going to cancel out. That would just double it, or square it, actually.
Would you
No,
divide
you divide. What am I going to divide both sides by?
V2
That's correct. So V2 is canceled out here. You see that? Where will I put V2 on the other side?
on the bottom?
That's right. So your new final equation is T2 times P1 times V1 over V2 times T1 equals P2. Okay? All right, let's do an example problem. Oops. All right. A gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 degrees Celsius and the pressure increases to 480 kilopascals, what is the new volume? So the first thing I would ask you guys to do is to identify all your variables. There are 6 total variables in this problem. 5 of them are provided to you. So let's see if you can identify all 5 in any given order. So let's start with Scout. Can you tell us any of the variables? Tell me which one's which. V1 is 2.00 liters, correct? Tim, tell me another variable that we are provided. T1 is 30 degrees Celsius, correct? Kevin, tell me a third variable that we are provided here. P1 is 110 kilopascals, okay? 2 down, 3 down, 2 to go. Nick, can you tell me a fourth variable that we are provided in this problem? P2 is 440 kilopascals. And let's go to Kayla. What is our fifth and final variable that we are provided here? 80.0 degrees Celsius. That is correct. So what variable were we not given here, Jade? Which one? V2. And what is the first volume measured in? So the second one will also be measured in liters. Okay, guys, so if you set up your original equation, like so, P1 times V1 over T1 equals P2 times V2 over T2. If you're a little rusty on the whole algebra, this is why you come to class. So we are given V1, we're given T1, we're given P1, we're given P2, we're given T2. We have no idea what V2 is. Okay, so Mr. Max, what's the first move I should do in trying to isolate V2 so that we may solve for it? That's right. On how many sides? Both sides. Good. So T2 is going to be multiplied on both sides. That will cancel out T2 for us. So right now, as it stands, we have T2 times P1 times V1 over T1 equals P2 times V2. Okay? Colby, I'm trying to get V2 by itself. How are we going to do that? Max got us through step 1. Divide both sides by P2. That would be correct. So our new formula is going to be V2 equals T2 times P1 times V1 over P2 times T1. Okay? We now have our equation. Now you can just simply plug and chug. So let's see. T2 was, actually both temperatures are in Kelvin, so you need to change that first. 80 plus 273 is 353. 353 Kelvin. P1 is 110 kPa. And V1 is 2.00 liters. P2 is 440 kPa, kilopascals. And T1 is 30 degrees Celsius, which is 303 Kelvin. Now, do you guys see any common units of measurement? Like, what units of measurement are going to cancel out here? Kelvin and Kelvin cancel out, and kPa and kPa cancel out. So what will your answer be measured in? Liters is correct. Now, I want to show all my work so everybody can keep up. So I'm going to multiply the top, and I'm going to multiply the bottom first before I do any division. 353 times 110 times 2. I have 77,660 liters over 440 times 303 is 133,320. I then do 77,660 divided by 133,320, and I have 0.58 liters. Did you get that? I'm sorry? Okay, so temperature went, let's see, temperature went down. And pressure went up. So the volume, see, went down. Hmm?
I thought if temperature goes down, pressure goes down.
No. These two are inversely proportional. Yeah, I know. So this is going to be, you want to focus on the one that you're given and compare it to the temperature. Don't compare it to the pressure. So that if the volume and temp are directly proportional here, that was a direct proportionality. Focus the one that you are looking for and compare it to the temperature, okay? Don't compare the two that are given. Like with temperature and pressure, I understand that those two are going to be directly, but you want to focus the one that you're looking for with the other two factors, not the two that you're given. Yes. Here's some whispering. Max, what's up? 0.58 liters. What's the matter? Do I have the right number of sig figs? I think I do. Yep. If you look at your original numbers here, guys, if you want to talk about sig figs, oh, where are they? There they are. How many sig figs are in 2.00? How about 30.0? How about 110? 2. How about 440? How about 80.0? So your answer should be in 2 sig figs. That 0 doesn't count, but the 2 numbers after 0 do. Okay, here's what we're going to do. I am going to post your homework onto the screen. If you want to knock out a problem or two, you have time. This will be posted on a Canvas, and I'll text you when that is.